Good morning, folks. How you doing? We're going to be talking about constant acceleration today. You should have this worksheet in front of you. Yesterday we looked at a very quick video about constant acceleration, and of course gravity is one of the more common types of constant acceleration that we'll be dealing with. And so now we're going to be looking at a variety of kinematics problems where the acceleration is constant. And so here we've just got a summary of some constant acceleration formulas. Now we can see that we've got them all listed here, but we need to define what each of our pronumerals mean. So we'll start with u, and generally when we see u is going to be the initial velocity. So just fill that in, initial velocity. V is going to be your final velocity. A, your constant acceleration. And finally, S is the distance traveled. And you can see we also have T in these formulas, and obviously T is the time taken. So for general constant acceleration problems, it's going to be a use of either one or more of these constant acceleration formulas. I suppose the data that you have available will often dictate which formula or formulae that you use. So let's look at the first example where it says that we have a car with initial velocity of 12 meters per second. Okay, so straight away I'm going to say that u equals 12. Travels in a straight line, and that's important because all of our constant acceleration questions are dealing with straight line motion. A constant acceleration of 6 meters per second, so I'm going to write that down as a equals 6. This happens for 4 seconds, so t equals 4. Okay, good so far. Find the final velocity. So we're going to picture a car which is traveling at 12 meters per second. The acceleration is increasing. This happens for 4 seconds. What's its final velocity? We're going to go with the first constant acceleration formula where v equals u plus at. So the final velocity will be u, which is 12, plus 6 times 4 for a times t. It's going to be 36, I'm going to check units of measurement, 36 meters per second. What is the distance covered? So for this 4 seconds, what was the total distance covered? Now we've got a choice here, s equals u2 plus half at squared, or s equals half outside of u plus v all times by t. It's up to you. I'm going to go with s equals half u plus v all times by t. S equals half initial velocity, which is 12, plus the final velocity of 36. This happened for 4 seconds. Four times a half will give me 2, and inside I've got 48. So 48 times 2 is going to give me 96 meters. Okay, so that's a simple use of some of the formulas in the first example. Let's look at example 2. Example 2 says the brakes of a car reduce its speed from 36 meters per second to 24 meters per second while it covers 120, oops, this should say meters. Just fix that. Assuming the deceleration is constant, find how much further the car will travel before coming to rest. Okay, let's think about this. A car is slowing down, it travels 120 meters. How much further will the car travel before it comes to rest? So I can think about this a couple of ways. What I'm going to think about is there's the first part of the journey where it covers that 120 meters, and then there's the second part of the journey where it travels from 24 meters per second to 0 meters per second. Let's say if we look at the second part of the journey, initially the velocity is 24 meters per second, and the final velocity will be 0. Now, I don't have enough information because I would either need to know, well, I definitely need to know the time, or at least the deceleration. So let's look at the first part. This is for the second part of the journey. Let's look at the first part of the journey. For the first part of the journey, the initial velocity is 36, final velocity is 24, and they've told us that the distance travelled is 120 meters. Now, based on this, I'm trying to think, what can I find? Now, I do know from my formulas above that v squared equals u squared plus 2as. So based off of this, I can find the deceleration, and that's what we're going to do. So we're going to use v squared is equal to u squared plus 2 times a times s, which for us is 120, and I should be able to find a. And you solve, what have I got? 24 squared is 36 squared plus 2 times a plus 120. Tell me what a is. -3. I'm happy I got a negative there because the question was talking about deceleration. Meters per second per second. Okay, so that's good. We found the constant deceleration. And so we know for the second part, the initial velocity is 24, final velocity is 0, and this deceleration is going to be -3. How much further will the car travel? I still need to find the time that it travels for the second part. So what I'll do is I'm going to use u equals v plus at. So back to the second part. Not 24. The final velocity, we're using v equals u plus at. 0 is equal to 24 plus a times t. I can see that t is going to be 8. So I now know for the second part, the time is 8. So for the distance travelled, I'll use s is equal to half outside of u plus v all times by t. Use 24, final velocity is 0, time is 8. Half times 8 is 4, 4 times 24 is 96. So the distance travelled would be 96 meters. Let's look at this last part. The time taken for the car, the time taken to come to rest from the initial speed of 36. We know that the second part took 8 seconds. So I could go find the first part and add the times together. Or I already know the initial velocity. Initial velocity was 36. We know the final velocity is 0 and the acceleration is -3. So let's just use v equals u plus at. So v is the final velocity, u was the initial velocity, which was 36, plus a times t. What have I done here? Wait, what am I trying to find? The time taken. Oops. Final velocity is 0, initial velocity is 36. Deceleration is -3, and there's t. Now we can solve t is 12 seconds. So that's better. So in approaching these problems, it's a case of establishing what values they've given you, which formulas we need to use to solve the problem. And you can see from example 2 part A, sometimes there's multiple parts of a journey and you have to work with the correct part first. So please spend the remainder of this double looking at exercise 19C questions. It is quite long, does require a lot of problem solving. Next week, we're going to move straight on to finishing this chapter and looking at 19D. Thanks, guys.